Welcome back to the deep dive. I am just absolutely thrilled to have you with us today. We've got a really fascinating stack of sources to go through. And, well, I want to start by asking you to imagine something.
Always a good way to start.
Right. So picture holding a crystal ball in the palm of your hand. But, instead of like mystical fog swirling around inside it, it's a hyperdense web of code. And it's running quietly right there on your laptop's hard drive.
Uh-huh.
You feed this crystal ball a press release or maybe a new government policy or, even just a bold new business idea. And before you ever share it with the real world, you get to watch exactly how society is going to react.
It's like you literally get to test drive reality.
Exactly. You test drive reality. And today we are unpacking a source that basically gives you the blueprints to build that exact crystal ball on your own machine.
Which is just a staggering concept, when you really think about it. And our mission today is to explore how cutting-edge AI is actually making this possible.
Yeah.
Because we are looking at a fundamental shift here. These massive, complex simulations, they're moving out of those giant corporate cloud servers and coming directly onto personal computers.
Which is huge.
Right. And the goal here is wild. It's about simulating entire societies and public opinion in real time.
Okay, let's unpack this. We're looking at a GitHub repository for a project called MiroFish-Offline, and it was put together by a developer who goes by the handle Nick McFly.
Yep, Nick and Fly.
And the documentation describes it as an offline, multi-agent simulation and prediction engine. Just reading through the capabilities, it really feels like we are crossing a major threshold in what personal computing can actually do.
Oh, absolutely.
But for anyone listening who might be picturing, just standard chatbot, we really need to clarify what this actually is.
Yeah, we do. Because to understand MiroFish, we have to look at the mechanics of a multi-agent swarm intelligence engine.
Right. Swarm intelligence.
Exactly. Usually when you interact with an AI, it's a one-to-one relationship, right? You ask a question, and it generates an answer.
Like a super smart search engine.
Basically. But MiroFish completely upends that dynamic. Let's say you upload a document. Maybe it's a highly controversial draft for a new corporate policy.
Oh, boy.
Right? Something that's going to make people mad. The engine doesn't just read the text and summarize it. It uses a framework called OASIS.
OASIS, right.
Yeah, which was developed by the Camel AI team. And it uses that to generate hundreds of unique, distinct AI agents.
And then it just drops them into an environment that mimics a social media platform.
So it's like playing The Sims, but instead of, building houses and agonizing over the wallpaper, you are building a simulated Twitter or Reddit ecosystem from scratch.
That's actually a great way to picture it.
But I have to push back here for a second.
Sure, go for it.
Isn't this just a fancy text generator spitting out fake posts?
Yeah.
I could just open up a standard AI model right now and tell it, hey, write 50 angry tweets and 50 happy tweets about my new policy.
You could, yeah.
So how does this qualify as a true simulation? Well, what's fascinating here is the crucial difference lies in the interaction. These agents, they don't just broadcast into a void.
Okay.
They actually interact, they argue, and they influence one another. It's a true swarm simulation because the system tracks sentiment evolution and topic propagation literally hour by hour.
Wait, so they're reading each other's posts?
Exactly. So if Agent A posts a scathing critique of your policy, Agent B, who possesses a completely different simulated background, might read that post, get outraged by the critique, and reply to defend you.
Oh, wow.
And then Agent C, who is maybe initially neutral, reads the argument between A and B, and they change their own underlying opinion based on who made the better point.
So it's capturing the actual friction of human debate.
Yes.
It's not just generating output. It's
Right.
simulating persuasion and, digital factions and virality.
Right, it's a whole ecosystem.
But getting hundreds of AIs to act like real, flawed, highly opinionated people, that requires some serious scaffolding. You can't just throw a bunch of code in a folder and say, act like a crowd.
No, definitely not.
The documentation outlines a highly specific 5-step workflow to build this simulated world. Let's walk through how it actually constructs this reality.
Yeah, the world building process is incredibly methodical. So step 1 is the graph build phase.
Graph build. Okay.
Right. The system reads the document you uploaded and uses local language models to extract all the entities.
Meaning what exactly?
That means it identifies the specific people, the companies, concepts, and events that are mentioned in your text. And then it maps out the relationships between all of them to build this comprehensive knowledge graph.
It's essentially building like a giant detective's corkboard
Yes.
with the red string connecting all the key players, so the AI has a foundational understanding of who is who and what is at stake.
That's the perfect way to picture it. And once that board is built, the engine moves to step 2, which is the end setup or environment setup.
Right.
This is where the simulation generates those hundreds of personas. And the system doesn't just, give them a name and a generic profile. It wires them with highly specific quantitative traits.
Like what kind of traits?
Every single agent is assigned a unique personality, a baseline opinion bias, an influence level, a specific reaction speed, and a persistent memory of past events.
Hold on, let me stop you there. It assigns biases and reaction speeds.
Yep.
That sounds like the system is intentionally coding internet trolls and slow reactors.
Pretty much.
But if you have hundreds of these agents running around a digital sandbox, how does the system possibly keep track of who is who, let alone what their specific grudge is against a given topic?
Well, that is the core technical hurdle of any multi-agent system. Right?
Yeah.
And it's solved through the memory architecture.
Okay.
The system maintains both individual memory and group memory. So it doesn't just flag an agent as angry. It gives that agent a memory base, which ties back to that knowledge graph from step 1 that justifies why they are angry.
Oh, I see.
So let's say an agent with a massive influence level and a lightning-fast reaction speed spots a news drop in the simulation. They react immediately.
Naturally.
Right. And their followers, agents who are programmed with lower influence and who inherently trust this leader, they read that reaction, update their own individual memories, and shift their opinions accordingly.
Which means you basically get to watch the mechanics of an internet pile-on happen in slow motion.
Exactly.
So we have this massive cast of AI characters all wired with specific biases and memories. What happens when you actually press go and drop the controversial document into that environment?
That brings us to step 3, the simulation phase. This is the period where the agents are unleashed.
The chaotic part.
Very chaotic. They post, they reply, they debate, and their opinions drift based on all those interactions.
Yeah.
But, a simulation of hundreds of agents screaming at each other is just noise if you can't parse the data.
Right. I mean, if you just wanted to see a chaotic timeline, you could just open real social media.
Right, we already have that.
We need to actually extract insight from this, which is where step 4 comes in.
Exactly. Step 4 is the report phase. And the system doesn't rely on some basic text summarizer for this. It deploys a highly specialized entity called the ReportAgent.
The ReportAgent.
Yeah, think of it as a relentless, simulated data scientist. The ReportAgent analyzes the aftermath of the entire simulation by interviewing a focus group of the agents.
Wait, it interviews them?
It does. It asks them directly how they felt about the events and why their opinions shifted. Then it searches that original knowledge graph for hard evidence to back up its findings before finally writing a structured analysis.
Now, the documentation gets pretty deep in the weeds on how it searches for that evidence.
It does get a bit technical there.
Yeah, it mentions a hybrid search formula, specifically weighing the search as 0.7 times vector similarity plus 0.3 times BM25 keyword search.
Right.
For anyone listening who doesn't dream in search algorithms, what does that math actually accomplish?
Well, it solves a massive problem in AI comprehension. Vector similarity. That's the 0.7 portion of the formula is a semantic search.
Meaning it looks at the meaning.
Exactly. It looks at the underlying meaning of a phrase by turning words into numbers or vectors. This is crucial because it understands context, even if the agents use slang or sarcasm or weird synonyms.
Okay, and the BM25 part?
BM25, the 0.3 portion, is a classic, rigid algorithm that looks for exact keyword matches.
So by blending them together, the ReportAgent gets the best of both worlds.
Precisely.
It ensures the AI understands the sarcastic tone of a simulated tweet, the semantic meaning, while still noticing that the tweets specifically tag your CEO's exact name.
Right. It captures the nuance without losing the hard facts.
And it does this automatically, compiling a massive dossier of simulated public opinion.
It's brilliant.
But the workflow doesn't stop at reading a static document, because step 5 is the interaction phase.
Yeah, and this is where it gets really wild.
This is the part that genuinely gave me chills. You don't just read the ReportAgent's findings and call it a day. You, the human user, can step into the simulation yourself and chat directly with any of the agents.
It's so cool.
You can literally pull Agent 45 aside and ask, hey, I noticed you posted a furious reply 3 hours into the simulation, but then you deleted it and changed your stance. Why did you do that?
And the crazy part is the agent will answer you.
Right.
in character, drawing on its persistent memory of the arguments it had with other bots.
It allows for, like, qualitative interrogation of the data.
Yes, because a pie chart can tell you that 40% of the simulated public hated your policy. Conversing with the agents tells you why the argument resonated.
And what specific talking point triggered their anger.
Exactly.
It's just an incredible capability. But to truly understand why this specific GitHub repository by Nick Engfly is causing such a stir among developers, we have to talk about the offline part of MiroFish-Offline.
Yes, the offline part is key.
Because looking at the history here, this wasn't always a private tool you could just run on your laptop.
No, not at all. The original MiroFish project was a massive, highly complex undertaking built primarily for the Chinese market.
Okay.
It had a Chinese user interface, but more critically, its entire architecture was inextricably tied to cloud infrastructure.
Meaning it relied on outside servers.
Right. To manage that massive knowledge graph and all those agent memories, it relied heavily on a service called Zep Cloud. And to actually power the brains of the agents, it sent continuous API calls to cloud-based language models like DashScope or OpenAI.
Which means every single piece of data, every confidential document you uploaded, and every simulated interaction had to be beamed up to a server somewhere else.
Yep, completely out of your hands.
But this fork completely severs those cloud dependencies.
It does.
The developer translated over 1,000 strings of code into English and entirely rebuilt the underlying tech stack so the whole thing can run locally. How did they actually replace all that heavy corporate cloud infrastructure?
Well, the new local stack is just a masterclass in modular engineering. To replace the cloud-based memory and graph storage of Zep Cloud, the system now uses Neo4j Community Edition 5.15.
And that's running locally.
Right, running locally. And instead of pinging OpenAI servers to generate the text, it utilizes Ollama.
Oh, Ollama's great.
Yeah, Ollama is a tool that lets you run powerful open source models like Qwen 2.5 or Llama 3 right on your own machine.
Amazing.
And for those embeddings we talked about earlier, the process of turning text into numbers for the hybrid search, it uses a local model called Nomic Embed Text.
So instead of renting a brain from a massive tech conglomerate, you are downloading the brain and locking it inside your own computer.
That's exactly it.
And reading through the repository, the developer didn't just hack this together with digital duct tape. They built a clean abstraction layer into the code, specifically a graph storage interface.
Yes, which is so smart.
Meaning, if you don't like Neo4j, the system doesn't care. You can swap in a completely different graph database without breaking the whole simulation.
The architecture is incredibly resilient. The developer also utilized dependency injection via a Flask app, ensuring there are no global singletons in the code.
Okay, I want to translate that for you, the listener, because it's a vital detail if you're trying to understand how this code handles so much chaos.
Good idea.
In programming, a global singleton is essentially like having only one pen in a classroom of 300 students. If everyone is fighting to use that one pen at the same time to write down their thoughts, the system crashes.
Right, it's a bottleneck.
Exactly. So by using dependency injection, the architecture essentially hands every single AI agent its own dedicated pen. It allows hundreds of them to write their thoughts and argue simultaneously without the code tripping over itself.
The software design is brilliant, honestly. But, we have to address the physical reality of running this.
The hardware.
Yeah, the hardware. Orchestrating hundreds of autonomous AI agents locally is incredibly taxing on hardware. The documentation lays out some strict requirements.
What are we talking about here?
Well, the absolute minimum to run even a smaller 14 billion parameter model is 16 gigabytes of system RAM plus 10 gigabytes of video RAM on a dedicated graphics card.
And if you're listening to this on a standard ultra-thin work laptop right now, you are going to struggle.
You really are.
The recommended specs are 32 gigs of RAM and 24 gigs of VRAM. That territory usually requires a high-end consumer gaming card or a professional workstation.
Yeah, it's hefty.
The repository does note that you can run the simulation on CPU only, but it comes with a massive warning that it will be significantly slower.
Because CPU processing is sequential, whereas a GPU excels at parallel processing. If you rely on a CPU to simulate hundreds of simultaneous conversations, you're going to be waiting days for your focus group to finish arguing.
Ouch.
Yeah, the GPU is what makes real-time swarm intelligence feasible.
Here's where it gets really interesting, though. If you need this kind of beefy hardware, and you have to configure Docker containers and download massive local models, why go through all the trouble?
That's the big question.
I mean, Cloud APIs from companies like OpenAI are so frictionless. You just plug in an API key and the cloud does the heavy lifting. What is the actual tangible benefit of cutting the cord and forcing this all onto your own hardware?
If we connect this to the bigger picture, the benefit comes down to one non-negotiable factor for modern organizations:
Such as,
absolute privacy.
ah,
Consider the stakes for a Fortune 500 company. Let's say they are drafting a highly confidential press release about a major corporate acquisition or maybe a massive round of layoffs.
right.
Or picture a hedge fund testing a proprietary trading strategy based on shifting market sentiment. Legally, ethically, and strategically, those organizations cannot feed that sensitive information into a public cloud AI.
Because someone else owns that server.
Exactly. There is always the risk it might be absorbed as training data, or worse, leak in a data breach.
Ah, okay. So zero cloud dependencies isn't just a fun flex for open source hackers. It's a corporate shield. It means zero data leaks.
Exactly. What happens on your machine stays entirely on your machine. You get the predictive power of a supercomputer swarm combined with the security of a concrete vault.
Wow.
You don't have to trust a third-party terms of service agreement because the data never leaves your desk.
That perfect combination of privacy and predictive power opens up some wild real-world applications. The documentation lists 4 specific use cases, and I want to run through them because they really highlight how transformative this could be for you, regardless of what industry you're in.
They're great examples.
The first, as we touched on, is PR crisis testing.
Right. Instead of a communications team sitting around a table trying to guess how the public will react to a controversy, they can feed the raw document to the swarm.
And just watch the fireworks.
Exactly. They can watch the simulated public tear the press release apart, identify the exact sentences that trigger outrage, and revise the draft before a single real human ever reads it.
The second use case is trading signal generation. You feed the engine a stream of complex financial news and observe how the simulated market sentiment shifts.
Which is incredibly valuable.
You're basically building a synthetic stock market floor on your hard drive to see how retail traders or institutional bots might panic or rally based on a headline. It's anticipating market volatility before the opening bell rings.
And then the third application involves policy impact analysis. Local governments, city councils, or federal regulators can test draft regulations against a simulated public response.
Oh, that's smart.
It allows them to locate the friction points and understand why a certain demographic might push back against a new tax or zoning law.
But the fourth use case, this is the one that completely blew my mind: creative experiments.
No, this one is amazing.
The developers actually fed the engine a classical Chinese novel that had a lost ending.
The results of that experiment are a remarkable testament to how flexible this engine is.
Wait, let me make sure I have this right. A swarm of AI agents simulated the characters, the authors, and the audience of a classical novel to crowdsource a lost ending.
We did?
That is like having a million ghostwriters trapped in your computer, all staying perfectly in character, arguing over the narrative until they produce a consistent conclusion to a centuries-old story.
It's unbelievable.
How does an engine designed for PR crises even know how to write a novel?
Because the underlying mechanics are the same. The engine tracks memory, personality, and relationships. It naturally understands narrative arcs because a narrative is just a series of interactions and consequences.
Okay, that makes sense.
Right. The agents read the preceding chapters, absorbed them into their persistent memory, and then simply interacted within the constraints of the world they were given. They organically debated and produced an ending that made logical and emotional sense based on the established graph.
So whether you are an executive trying to navigate a tricky communication, a researcher studying how misinformation spreads, or just someone who is insanely curious about the future of technology, this tool represents a fundamental shift.
It really does.
It's an on-demand, private focus group. It forces you to step outside your own echo chamber and confronts you with the good, the bad, and the heavily biased reactions before you make a decision in the real world.
It challenges your assumptions before the real world has a chance to punish you for them.
Exactly. It's the ultimate reality check, performed safely inside a digital sandbox. So, just to recap the journey we've been on today. We started by looking at the original MiroFish, a complex cloud-dependent tool built for the Chinese market.
Yep.
We explored how the Nick McFly GitHub fork translated it, severed all the cloud APIs, and localized the entire tech stack utilizing tools like Neo4j and Ollama.
And embed text.
Right. And by doing so, it created a completely private, offline engine capable of stress testing everything from corporate PR crises to the lost endings of classical literature, all while keeping your data perfectly secure.
And, understanding the mechanics of this engine, it raises an important question. And it's something we all need to deeply consider as this level of simulation becomes highly accessible. Think of the implications. If tools like MiroFish-Offline become standard, if they are sitting on the laptop of every PR manager, every politician, and every media strategist, we are going to enter an era where every single public statement, policy, and piece of media has already been aggressively stress-tested by simulated societies.
They will have already argued with our digital ghosts before they ever speak to us.
Precisely. When everyone is perfectly tailoring their messages to beat the simulation, when every word is calculated to perfectly bypass our outrage or meticulously manufacture our consent, does our actual reality just become a reflection of what the AI already predicted?
Wow.
When the news breaks and we react, are we reacting organically, or are we just playing out the exact script the swarm already finalized on some strategist's hard drive?
That is a heavy, heavy thought to leave you with. It's one thing to look into the crystal ball. It's an entirely different reality when you realize the crystal ball is starting to direct the play. Thank you so much for joining us on this deep dive. Stay curious, keep questioning the world around you, and, well, if you've got the hardware for it, maybe try spinning up a simulation of your own and see what the swarm has to say. We'll catch you on the next one.